We saw last time, if we start with a particle A moving at initial velocity VA initial, at some later time it's going to collide with another particle B. Then afterwards, we're going to see A is going to be moving with some velocity VA final. B is going to be moving with some velocity VB final. And this is even true if B had some small initial velocity where the initial B velocity is less than the initial A velocity, so that eventually the collision would take place. But then we saw that there was a conservation law. We saw that the momentum of A initial plus the momentum of B initial was equal to the final momentum of A plus the final momentum of B. So this is really what we mean when we're talking about the law of the conservation of momentum, is that the sum of the initial momentums is equal to the sum of the final momentums. Right? So if we look at our final momentum for A, that's going to be equal to our initial momentum minus this quantity that your book writes like this. And they call this the impulse. So the impulse, this is the amount of momentum that was transferred from A to B. So because of that, that means particle B has a final momentum that's equal to particle B's initial momentum plus the impulse. So the impulse is really just saying what's the amount of momentum that was transferred during the collision. So A lost an amount of momentum, which is exactly equal to the amount that B gained, right? This is what the conservation law is telling us. So in the next lecture, or in the next unit, the next module, we're going to look at what actually changes the momentum of the two particles during the collisions. And we'll see that that's something that we call a force.